And I think your work on converting things into mini-seed format in the cloud makes everything much easier. So I think it's sort of okay to sort of think of the firmware as just sending data, but there's there's everything else that happens before once it gets into the cloud, and aside from the visualization, which I think maybe in a few weeks we can start to share bits and pieces of.
Yeah, I had a quite a big presentation today for the institute that I'm working on, and there is plenty of seismologists, and I think that maybe it raised some interest. And we might have some seismologists joining OpenEEW and helping us with the seismology side of things. So that would be great. We'll see what comes out, but a few people were interested in detection, so that would be nice to test out different kind of detections. Yeah, so we'll see. Hopefully they will join.
Must be lonely being the only seismologist here.
Yeah, I feel lonely.
Nice. So in the meantime, though, so it seems I know Drew has put those pull requests. Does it make sense to merge those as is? They're not going to do any harm to the existing code, and then we can apply them later to the new code base down the road.
Yeah, they're all useful. Yeah.
Yeah, but let's test them first, right? We don't know if they're the pull request. The one pull request that merges the time sync needs a little more investigation.
Oh, is it? Did you get time to go through that?
I'm looking at it now. The first time I've had a half hour.
Yeah, I think the GitHub action was kind of harmless, right? It's kind of an enhancement. It doesn't really do anything outside. But yeah, I agree. Those were a little bit more involved, the other two.
Yeah.
Yeah, so that's what I tried asking on Slack, whether this approach will work. I mean, I don't exactly understand currently how you are sending the payload. What is the way you're handling time locally on the device? So what I saw was that you were using that inbuilt time function, that is the time since epoch. So it counts the seconds from epoch, but that's not really a good approach, is what I feel. I feel that with the help of this library, you can directly get a character string of the current time to the accuracy of nanoseconds or microseconds, and then you can just send this string of microseconds date time directly to the uh, cloud in the form of the payload. So
yeah, that I think. So I'm gonna have to look through it. But by no means was my time function, which I stole from other, open source projects, particularly efficient. And didn't use NTP time. It just used the time servers.
Yeah.
But the string you were proposing to send is different than, or we're sending milliseconds from. We're not sending UTC timestamps. We're sending epoch timestamps. We just have to format maybe the timestamp differently.
Yeah. But I mean, is it not better that we are getting the current time compared to the epoch time, or is your server end configured in such a way that it would be difficult to change the time format right now?
No, that would be that. I think that would be easy to read whatever time format from the message. But how does your version of the firmware go around like syncing the time with the server? Because there is the internal clock of the ESP32 is biased always. So how often do you sync, or how does that work?
So in my experience, it's pretty low latency. So I don't think we would face much issues. But obviously, we could go about testing this if we could somehow. I mean, I tried it with Watson IoT, but I couldn't really understand the device setup thing.
Mm-hmm.
So I couldn't see it on the cloud end, but in the serial monitor, at least I was publishing the data and getting the code to run.
So you run it on the second core, and how often do you sync it at the moment?
No, so right now I have not done the second core part because I was waiting for this NTP code to get approved first, and then I would So again, what would be the benefit of second core? I mean, if we were to do it on the second core, then we would need to change the approach a bit. So what we could do is maybe this code runs continuously in a infinite loop on the second core, and then you sort of just request at the time of sending the data to the cloud that okay, now I need the time string, and then you send it to the cloud. Or what were you
So
having in mind?
yeah, so this is I was actually playing with timing a lot in the recent weeks. So I did both GPS and NTP, and I was trying to get like a millisecond-ish precision. And the idea of the second core, at least in my mind, and I'm not a C++ programmer by no means. Like my style is Control C, Control V. But the idea behind it was that the GPS, when it's connected, it sometimes loses satellites or
Right.
stops working, and then you don't want the main loop, the zero core, to be interrupted by
Okay,
like
okay.
resyncing or
Right.
researching the satellites.
Yeah.
So that's why I did the
Okay.
second core thing, that GPS runs independently, and then once it views
But
a signal, the firmware just keeps running, and
so
it tries to
I,
reconnect. The second core tries to reconnect the GPS.
yeah, yeah.
However, I'm sorry. One more thing. Then I started to play around with NTP, and I actually found out that NTP syncing takes just 1 millisecond. So
Exactly.
you have 32 milliseconds each loop, let's say, because one sample takes 32 milliseconds to collect.
Collect.
So
Right.
we have plenty of time in the main loop.
Yeah.
So
Yeah.
I was syncing NTP time every cycle, and because I was getting just 1 second, sort of like I resynced it like every time I got a new second, and I was counting milliseconds after that, which I was then attaching to the message, and it gave me, I think, plus or minus 1 or 2 millisecond timestamp comparing
Okay.
to GPS,
Okay.
which I think is plenty enough for us. And I still wanted to do more testing on that, but I think that in that case, we don't really need the GPS time, or we don't need the
Yeah,
GPS
you
module
don't.
in there.
No.
So like it looks quite promising.
Yeah, yeah.
However, I'm sorry for the long monologue, but if you have, like any of you have any experience with the timing of the accelerometer, because that looks like a slightly bigger problem, because although it says it should be 31.25 samples per second, the internal clock of each accelerometer, each board is slightly off, and I couldn't find a way how to. So it's normally a little bit faster. It's like 31.5, but it's not exactly the same. So once you run the sensor for 30 minutes or so, and you are creating a continuous trace, some sensors are just having a slightly higher sampling rate, so there is some extra samples. And I couldn't find a simple way how to slow down the sample rate of accelerometer. So if something comes to your mind, how to slow it down from the ESP32, or there is an option somehow externally sync it with some clock, but I couldn't really figure out how it works. So that would be really helpful, and I think that like this sampling frequency is a bigger problem in my mind right now than timing. I think the NTP timing works quite fine, but I
Okay.
think that the sampling rate would be, is sort of a problem. It's not a huge problem, but
Maybe
of
that should
the
become a
things
PR. Sorry, go ahead. An issue.
one of the things that I did with some of the sample rate things, I cut it off at 32 samples. So I only saw like every once in a while there'd be a couple extra samples in there, but I just like sliced the array per second to just, if it went over 32, I just discarded it. But I could see where that's because you're stretching out the time and trying to push it back in again. So it's kind of a mess.
yeah. So were you doing it in a firmware, or were you doing it on the receiver end that you were cutting it off?
I was doing it on like the real-time playback displays of, I was taking like the traces of X, Y, and Z and playing them back in real time. And every once in a while, it would pop up, like it would alert me in some of the scripts that I wrote, oh, you have some extra samples here. So I had seen it, but not that often actually.
I don't know if hardware suggestions are welcome, but have you considered using the LSM9 DS1 9-axis IMU?
I tried it. I tried. Sorry, who makes that one again?
It's a 9-axis IMU, LSM9 DS1.
I tried one from that family, but how
Okay.
good is the noise level on that one? Do you know?
Not really. Actually, I have a board in which I'm using it, and but my applications are obviously simpler ones like gesture control and things like that.
Things might have changed, but 2 or 3 years ago, or actually 4 years ago, when we did a thorough investigation, we tested about 15 different accelerometers. There was only one other one that had that was as good as the ADXL 355 in terms of noise, and that one was made by Colibri, a Swiss company, and cost about $300. And that was without all the circuitry you needed. That was an analog one. So this is the only digital one that we could find, which had a sort of noise threshold that was good enough. All the other ones are pretty useless unless you have an earthquake right underneath you. So yeah, I mean, eventually that would be okay, but you wouldn't get much data to work with, and you'd be waiting, years before you saw earthquakes.
Silence. Yeah. No, I think that we
Okay,
can.
so
Sorry. Yeah, sorry.
Yeah, so I just wanted to pitch in that if we are going to work with dual core, then one thing to definitely keep in mind is you never keep the core idle. None of the cores are supposed to keep idle, because that's the issue I was facing when I initially started with dual core programming. And I think the earlier function that was there in place for time, I had just shifted it to the second core. And what was happening that the function was not exactly running in an infinite loop. It was just being requested once or twice in the code, and then the rest of the time used to be idle. So whenever this idle state of a CPU core is detected, the ESP throws Guru meditation error. So we have to keep in mind that if you're going to use two cores, then we have to keep the task continuous. There should be no interruption of tasks on either of the cores.
Okay.
So I suggest that maybe we can have one loop on the core one, which is for, say, sensor reading. So it keeps on reading the sensor. And then on the second core, I mean core 0, we have the time sync, which syncs time with a delay of, I don't know, whatever you want, say 1 millisecond or whatever. And then this keeps updating the, say, global or static variable called time string. And then there is no question of, requesting the function from one core to another core for getting the time. You just have a static variable that is common to the entire code, which gets updated every millisecond or what, and then you won't have much issues. That's what I feel. It will make things simpler.
But as Václav just said, he managed to get the NTP working with a single core with millisecond precision. Is that right?
Mm-hmm.
So maybe we should hold off a little bit and just compare maybe even test both of them.
We could.
Before we settle on one approach.
Right, because even dual core could be a overkill for our purpose. Could be.
Yeah. If we use NTP, I don't really see much of a reason right now to use dual core. I could see the reasoning in the GPS, but if we don't use GPS, then
because RTOS simply complicates things way more than they need to be. So unless we are really sure that we need parallel processing, then we should avoid the dual core.
I can try to finish up a few things on the firmware and then upload it. And,
definitely.
If you could go through it and like just comment on the stuff that I completely butchered, which is probably everything, I would be very grateful.
No problem.
So yeah.
Yeah.
I just wanted to mention that we just got another email, John, from Andreas Spies, the sort of the famous electronics YouTuber.
Oh yeah, right.
So he just wrote to me out of the blue again, and I'm a big fan of him. But for those who are not in my world, and he has a huge following of sort of like real hardware nerds, and he really and he's in love with the ESP32. All his videos seem to use them, and a lot of the stuff that we're into. So he just asked if we can make a video again about this project. But we do need, I think, to come together and sort of clarify a couple of things, right, John? I mean, there still isn't resolved what your average maker would do with one of these devices. I think that question is still, up in the air.
Yeah, and that's ultimately what you'd have to decide, like the onboarding experience. When we first were approaching Andreas, it was mostly about, hey, get a sensor and onboard it into the global community. And now we've shifted towards, get a sensor and build your own sort of network. And that's a very different, approach.
Yeah. I think I need to have a call with him and explain that. Yeah. His community. Sorry.
Wouldn't that fit what he's his community maybe even a little bit better, right? Because the whole idea of the onboarding was that it was abstracting out this whole process that conceivably makers would probably want to go through, right? Where they're building their own building their own devices, kind of manually connecting it up, all that. Like we were basically saying, we're going to handle all that for you and just connect you seamlessly in the background in the back. But it seems to me like maybe his community would appreciate the direction that we've taken on it a little bit more.
I was going to say pretty much the same thing. Yeah, they all do self-hosted solutions. They all enjoy playing around in Arduino, so there'll be no issues there. Okay. Well, yeah. I guess I'll explain to him then how the project's evolved into what John has explained, and if he's still interested, we've made good progress in terms of if you want to set something up. But having said that, maybe we should wait until we release things in a couple of weeks, because I think we do need to make it a bit clearer, at least from what Ignacio had to go through in terms of how you set up your own EEW. So give me 1 second. Someone's at the door.
So if someone could refer me to some proper steps for setting up Watson IoT, or
I thought I gave you steps. It's relatively easy.
okay, but I don't know. I couldn't see. I created an account. I created the thing, but I never got any of the secret files in the portal.
I thought you gave me the secret. Oh, I'll walk you through it. It's like 5 minutes, not even. Okay. I thought we did this like a month ago. No, I have to go back in my notes.
We were working with, I guess, AWS IoT. But I was working with Andy.
Ping me separate, and I'll just show you how. Because I put your credential into the Node-RED flow so that it would direct all this data to your org.
What's my org?
You sent it to me, I think.
No, I never really personally messaged you.
Well, let's take a look. All right, well, let's have. I don't want to take away from the rest of the community. They've got other topics.
Yeah, right.
Yeah, ping me, and I'll. I thought you provided.
Yeah, I've dropped you
in the flow.
Sure. Anyway, I think I'll take a leave. I mean, and if you guys feel, then maybe you can merge the actions PR.
Yeah, I think the action ones, I can merge that right now. I don't think there was any problem with that one.
Sure. Thanks.
Yeah, and then I'll push a small little piece of code. We could test it out, Adrian and I and you, if you want.
I've got to go, but great to meet you in person at Drova, and great to see everybody. Bye.
Thank you. Goodbye.
Any stuff on firmware that we should talk about? I keep missing the dashboard. I mean, I keep missing the dashboard meetings.
Yeah, so we had a pretty good meeting last Friday with the dashboard because, well, we left it 2 weeks ago. We had a horrible meeting with the dashboard because we couldn't figure out exactly what direction to take it in and how to sort of navigate. Kristen came up with some designs, but she was a little confused by what direction it might take now that we've kind of, decided to go another route from the global system. It's sort of having people easily set up a sensor inside the dashboard required answering a few questions with this new way, because now there's so many different ways you could potentially add a sensor to a network. But I think we sort of figured it out in just with a plan to basically make the dashboard, at least for starters, into its simplest form, right? And assume that, basically what we've talked about here in this meeting, right? Assuming that people can connect devices on their own, or, have it connected. Like if people buy sensors, for example, from Grio, like Andy, like we potentially set up the firmware to have an endpoint to whatever wherever the sensor is going to send data. Or if people set it up themselves, then they would have, they would set themselves, they would put that endpoint into the firmware. So it's sort of like we realized on Friday that the dashboard needs less automatic configuration than we originally thought. And really all we need to do is just connect, the process of connecting a sensor in the dashboard is really just giving it a longitude and latitude, right? Because the dashboard's already going to be connected up to whatever backend has already been set up with the dashboard. So there really is not the process anymore of having a sensor connect it through an endpoint via an account, because the one dashboard will equal one backend.
Yeah, of course. That makes sense. Yeah.
Well,
what happens if you're not using Cloudant?
So that's the thing, right? So my grand vision of this, I don't know when I would get a chance to actually do it. We probably should just throw it up as a issue, and maybe someone else can take it in the month of October. But my goal with it eventually would be to have some way that you could have a CLI walk you through setting up whatever cloud backend you want to launch OpenEEW on. I know it's a bit of an undertaking, so I don't know how fast it would be done. I think we get to version 1.0 before we do that. But part of that setup might be that you don't want any authentication, and you just want to build the backend yourself on your own local computer, right? Not even use some sort of cloud service.
Yeah.
And so, through things like AWS CloudFormation and IBM, the equivalent of that on IBM Cloud, or just different scripts, potentially we could, you could choose from the CLI what configuration for the dashboard and the backend that you would want. And then it all connects everything up. And then as part of that, it launches the dashboard, which is then connected to whatever backend you've selected. And so if that were the case, then we wouldn't, like I said before, we wouldn't need, each sensor would always connect to one endpoint on the back end, which then would be also connected to the dashboard. So the whole sort of configuration process for each sensor really is reduced down to give it a longitude and latitude and maybe assign it to an account, but the CLI might even let you skip the authentication, right? What if you don't want authentication? You just want to run on your computer. That's all modularized. It's all module at this point anyway. So we could take authentication out pretty easily from the dashboard if we wanted to. I wouldn't want to just throw away that code, but if someone didn't want it, then we could make it available. And And we were going to ask Václav from the dashboard meeting that right now. So so what's the status with like GPS time on the potentially in the new firmware?
So the GPS time is working, but as I was saying before, it may be unnecessary. So because the NTP can do just fine and very similar precision. So if someone has the GPS and wants to plug it in right now on that version that I'm working on, it works well. But like, for example, I was thinking that in Nepal, I would like to have all devices equipped with GPSs. And now I sort of, I still want to do more testing, but I reconsidered that because it's throwing a bunch of money, and not only about money, but it's also increasing sort of complexity of the device. You have to have the antenna and stuff like that. So if it can be done just through the internet, it's better. So I right now I think that we might not need, for like very good precision, we might not even need GPS.
Yeah, because you might find in Nepal that you get that there's the only location near the router is in a back room with no access to Windows, and so adding a GPS antenna is going to be horrific.
And really, like we have, I'm sorry, like we have no like location, or well, we would have location, but it would not help us. The location data is not crucial for anything. Like if we had a GPS that would give us really precise GPS data, that would be something else. And there's actually, I talked to this guy a few months back, and he's now researching options, like also from our institute. He's researching options if there is some low-cost GPS that could potentially plug into our sensor and give us, GPS data that we could actually use for like large earthquakes and stuff. But I don't think that it would be in the that it would be affordable or anything. And
no, that's a whole different range of GPS devices. I looked into that, into the GPS resolution. Like that's you're talking about hundreds of dollars adding. Yeah. That's something completely else. They're also power requirements, size. That's a bit of an issue.
Yeah. So like the small GPS would be really just for time, and if we can do with just NTP, like that would be probably a simpler way to go.
Okay, yeah. So that was Andrew and I were just talking about that on Friday, of just if potentially we could get, like, if it would be better to have somewhere in the dashboard where you put in the location, or we'd have some other means of getting that. And yeah, so I figure like that'll be part of the part where you add a sensor to the dashboard. You can just throw in, and then also give it a little more manual checking, right, to make sure you actually have the right longitude and latitude in it, if there's no other means.
Yeah, can I mention one of the things that I've done? Let me see if I can find it here. I'm going to share my screen. So in Puerto Rico, we were having a lot of trouble with Walmart because they are installing sensors in Puerto Rico. Can you guys see my screen?
Yeah.
So one of the things is I wanted them to change the firmware, also because there was an error with the firmware which they had on their devices, which couldn't be updated remotely. And so in doing so, I also changed to AWS because we have credits for a long time with them. But aside from all of that, one of the things I learned through this experience was I gave this page to the guys there who are installing, and basically what happens is I just tell them more or less that you need these things to install it, to change the firmware. And then I told them, you connect your sensor, then you have to install this software on your Mac or your Windows. Then I give them where to download this program, which opens up, and you can, in 3 clicks, upload firmware to your sensor. And then I tell them they have to sort of record the MAC address, which pops up on the window of this program, and just send it to me. And I give them some other information. If it's Ethernet, you don't have to use an app. If it's Wi-Fi, you have to use one of these apps to pass over the SSID and password. All I want to say is it's worked really well. And at the very last stage, I just created a very, very basic Node-RED dashboard. And all that happens is you put in your device ID, you press enter, and if it's connected, your device will get an earthquake alert. And so that means that they can check it themselves once they've finished installing, instead of having to wait for a dashboard to go green in the next couple of minutes or something. And it's worked really, really well. So I'm not sure how much of this is relevant to OpenEEW, but I just wanted to say that what worked really well was giving the installers, people who are doing this for us, the opportunity to test it by just sending an MQTT command, which I think we had in the dashboard anyway. But getting rid of the authentication app has made all the difference as well. Now people can just install without having the issue that they were having before.
Yeah. I mean, and that's the. I mean, we spent a lot of time on the authentication side of it, because basically the whole the dashboard, I don't know what the percentage is, but the dashboard is 40% onboarding at this point, because so much of the back end, I mean, the front end are maps, right? Which we are still sort of half finished. There was a lot of energy put into facilitating the back end portion of the onboarding, which made sense when we were trying to figure out the sort of global, easy to use system, which, at the time I thought was a really good idea, right? I thought that was the way it was going to go. If we could,
yeah, me too. Yeah.
The idea that we could get everybody on, simply, and people around the world to be owning these sensors. But as the reality of that, it became apparent.
Resolved.
We need, resolved. Really, we don't. I mean, unfortunately, we'll keep the code in there in case there's some sort of future use for it. But so much of the back end is geared towards onboarding the device now, and so if we just sort of minimize that to its technical parts, where people can do it themselves, it means that the dashboard is really just it's just the front end. It removes a lot of the complexity, which could potentially cause problems. So it really is now just a front end map and a way to visualize what events get created and a way to visualize sensors, and we'll leave it at that. And maybe in the future we'll add on some CLI tools to or some potentially tools to help set up all of this in the first place. But we probably don't need that for version 1.0.
I mean, I've now managed to guide a telecoms engineer in broken French to install them in Haiti, and I've also managed to guide a sort of a Spanish, heavy accented Spanish-speaking Puerto Rican Walmart employee as well. No issues. So we underestimated the capabilities of your average guy in terms of doing this sort of stuff.
Yeah, maybe if we can translate the dashboard to broken French, that would make sense.
Yeah. Johnny has pirate as one of the languages somewhere there. I don't know if you ever added the switcher for it, but it's somewhere in there. As far as if there's any pirate setting stuff up.
But I think what you said, Ryan, is completely right. I think that's all that authentication was built for the idea of the global network, and right now it's probably going to work slightly different. So I think that a lot of it we probably won't need on the dashboard. So
yeah. I mean, the original idea was to make it I always thought in my head it was like a Sonos speaker, right? And how quick and easy you can set it up, but the amount of development that's required to make something like that is I mean, you really need teams and teams of developers to be able to do that. So once again, software engineering, you have grand goals to start out with, and then you realize that the simplest form of it would probably have worked just as well.
Yeah.
Hey, so just out of curiosity, Václav, so Nepal is ready to go. What's the timeline there?
So right now I still don't have a flight ticket, but it looks like the 14th of November. It's our meet time with the collaborators in Nepal. So if nothing, so cross fingers, that's gonna be the date. So I should be going there about a week ago or a few days before then. And then, second half of November, we should be deploying stations and
eating dal.
And eating dal. Yeah, I'm very looking forward for that. Dal bal is really my favorite food. So, so it should be, happening in a month, a little bit more than a month. So I need to, the instruments are pretty much ready to go. I need to finalize the version of the firmware that I'm going to use, and then, somehow
And do you know?
Platform.
Sorry. Yeah. Do you know where they're going to go?
Not exactly yet. So I have a map of approximate locations, But so the way we normally did that, or we did that in Nepal and also actually other countries, is that we were going around the towns or villages where we knew we wanted a sensor to have in, and we were just going around and like finding good locations while being there. So communication with the local people was actually quite easy, and we were also able to offer a little bit of money for hosting a sensor. But it was a different kind of a sensor, so it has, like, in a way it was more difficult, but in a way it was easier. So it was out in a field somewhere, we dug a vault, we put a solar panel, and those were like big stations. So now it's going to be a little bit different because you're going to have to find a reliable internet and stuff. So if the communication with our Nepali counterparts was a little bit easier, I would like to pre-select some sites and pre-discuss this. Right now, it doesn't look like that's going to be an option. So we might need to stick with this finding location.
Couldn't you have found some money in your budget to get one of those guys to run around and make a map for you and send you photos and information?
Yeah, maybe. We have a coordinator in Nepal, which is a guy that I know quite well from our deployments in there. But yeah, he doesn't look that active in these things. So I still want to discuss with those people or with the organization that we collaborate with whether that would be an option. For example, like, you know, something similar to Walmart in Puerto Rico, some organization or police stations or something like this where we could just go. There is locations that I know that there is going to be very few. In most locations, I think it's not going to be a problem because it's in those lower Himalaya hills, and there is a lot of towns and villages, and, you know, internet is everywhere. There is going to be locations where I definitely want to have sensors, and it's going to be more challenging to get internet connection higher up in the mountains, like in the Annapurna Valley and Mustang. And it's quite important for me to have sensors up there because that's right about where the earthquakes will probably initiate. That's sort of like, the point where they like to nucleate. So I would like to place some sensors up there, and there are some places that I Googled that have internet, like hotels and stuff. I am not sure if I can get up there this winter because it's getting quite late in the season, and these places are 4,000 or 5,000 meters high. So I might not be able to get up there now, and I'll just stick with the lower locations, and then the next 20 sensors sometime next spring, I would place higher up. So this time, these 20 sensors, I plan to test out more like the connectivity and you know how the sensors work, how the all this data transmission stuff works, and then the other 20 sensors is going to be more that I think that then the seismology is going to start a little bit later on.
Okay.
So next spring. Yeah.
All I can say is the experience that I had in Mexico in comparison to and keep having in Mexico in comparison to the one I'm having now in Puerto Rico and Haiti is just so different. And I can't begin to explain the pain of having to go house to house in Mexico, and then having done that to have to revisit it 2 years later, you know, and then it's just, you know, financially it's a stress. It's a stress on every level. But I don't know if there's some way you can leverage these guys that you have there, because it's just so painful to have to do that.
It's probably a good point. I'll try. This is sort of a way how I am used to doing things, because with seismic instruments, you know, you always sort of do it this way. But I think that having these small low-cost instruments, it also opens up the door for not having to do it this way, because with those, you know, pricey seismic instruments, you always need to service them yourself, and no one can really do it for you because it's a lot of instruments and really complex stuff. But these, I think you are right, someone who could take care of it on a police station or Walmart or something that just makes it so you don't have to go there. I think that would be
And maybe the first thing you say to the people is, do you want to have an earthquake alarm? Not do you want to have a sensor? And you know, the sensor really is not so important to them.
Yeah, definitely. And Yeah, but like we didn't have problem before finding appropriate locations or finding people that would be willing to take care of a sensor. So I would hope that that's not going to be an issue. But yeah, like if I hope to still have the opportunity to talk to those people in Nepal once or twice before I go there. So I'll definitely raise this question whether it's possible to pre-select some sites and actually go to some places knowing that there's going to be a good location. So I think we would manage without that, but yeah, definitely it would be better.
Okay.
Yeah. So yeah, I'm excited though. Like it's shaping up, and I can't wait to have the sensors on the ground and stream data. So.
Yeah, exactly. I think the most exciting thing for me was in Mexico. We put them all down. I had no idea if these accelerometers were any good, until we got our first sort of magnitude 6, and we all scrambled to get the waveforms, and we looked at it and we were like, yeah, that's the seismogram. Very exciting.
Yeah, and not only Nepal, but we are having more and more sensors everywhere, and I think it's taking off, and we'll have really nice data soon. So I'm excited about that.
Oh, awesome. Hey, I haven't got any much more here to add. I don't know if you guys, Andrew or John or anyone else or Ryan, wants to say anything else.
Just one real quick question. Does the Python scripts that you have up on GitHub for OpenEEW, I've been playing with some of them. Is there a way through those Python scripts to get the real-time data? Or do we have to do it through MQTT? Or is it just, I have all the credentials and can log into AWS. I just can't see any data coming back.
You mean the Mexican stations, or what stations?
Yeah,
now?
yeah.
So I was doing it through MQTT, and I have some. Yeah, I don't think that there was in the Python that there was on GitHub. I think that's the original scripts from Griot, and I don't think that there was any way how to subscribe to that MQTT using those scripts. So I think I was just just using PAHO library to subscribe to that MQTT endpoint, and then translate it into formats that I wanted. So
Okay.
I can send it to you. It was very simple though. It was just a PAHO subscribe. If you have, it was very
absolutely. That'd be cool.
I believe. What was the topic name? Was it traces? What was the topic name that we were using?
Yeah, I looked at it not that long ago, and I think I posted it somewhere. It was it was very simple topic.
Andrew, I gave you the client certificates are the ones I gave you, right?
Yeah, for AWS. John already gave me the ones for the Watson IoT. I've already got like about 4.2 megs of logs from those sensors already whenever they trigger.
Well, all the ones that are in Puerto Rico are moving to AWS now, so it's good that you have. But they're going to a different AWS account, so whatever certificates I gave you wouldn't work there. But Mexico is always active, so it's good if you could train it on that.
Yeah, I'm running things through TensorFlow. I've got some cool things I'm working with that, and I played a little bit with EQ Transformer. It's kind of a new model for detection. But I'm kind of wanting to train it on really noisy data and like see what kind of comes out of that, like with real-time things. So periodically I'll download all of the data from the Mexico sensors, because I know that anytime that there's any activity, and I'll try to throw it in and see what it does. So I'm just kind of working with that and playing with spectrographs at the same time.
EQ Transformer is awesome.
Yeah.
Sorry,
if you want to, I have 1,000 cutouts of just earthquake waveforms and the same number of just noise samples. If you want to do like training of neural network for picking or whatever, I can just send you all of it, because I spent some time like picking earthquakes and doing cutouts and doing stuff. And so if that's the data that you would be interested in, I can just send it to you. And
I believe
doing it
it's you already have that up in GitHub. Is it? Because if you do, I think I've already downloaded it.
No, it's not. It's not on GitHub. There is some, like, I don't know, maybe 10 larger earthquakes that are on GitHub. But this
Okay.
is all earthquakes that were recorded by the Mexican network. Of course, these are the biggest ones that had like more than, I don't know, 5 or how many stations detected. But most of those smaller earthquakes, they have just 1 or 2 stations that detected the earthquake. But for training a picker, you don't need multiple stations for the single earthquake. So that those would not be good for locations, for example, because you cannot do it from 1 or 2 stations. But for training a picker, that's just fine. So there's actually much more than what was on GitHub. Yeah.
Perfect. Awesome.
Yeah, I can upload it somewhere.
Have you seen this thing called EQ Transformer? It's quite interesting, that stuff.
No, I don't know what it is.
What is it? Who did it?
So the EQ Transformer, it's basically TensorFlow, and they took the Stanford earthquake database from global stations everywhere, and they trained models on it. And I played with it a little bit. It's pretty cool. I was wanting to see how noisy I could get the data and still be able to pull things out for, just the Raspberry Shakes have incredibly noisy sensors on them, much more noisier than you guys' sensors. So I was just curious to see if, like, eventually down the road where other stations can actually feed in and with really noisy data to see what it would do. So
yeah, that's perfect to investigate that. Yeah, cool. Yeah, I'll send you all the data and you can play around with that.
awesome, appreciate it.
Yeah.
I was going to ask if we could kill 2 birds with 1 stone here, because we have to put together a sort of prerequisites package for London School of Economics for the AI class. So if you can make it like a Notion page or something really quick that you can just put some links to the data, some explanation of what it is, then Andrew could use that, and we could also use that for these other guys.
Yeah, it's going to be free birds because I promised the same thing to someone at the institute today. So
Okay.
I'll also
awesome.
give them this data. So yeah.
Awesome.
Do you know, Andrew? Do you know how the EQ transformer models work? Are they running a neural network on the waveform itself, or on like the spectrogram, or like just the?
They'll pick PNS waves. It's a read through the GitHub. It's really cool. They go into great detail about everything that it does and how they got, how the outputs and everything like that. So, but as training a picker with noisy data is a little bit difficult, especially for the smaller quakes. Like when you get like underneath the 4, it really gets interesting to pull it out. So. And I've been writing like just straight out software for just in Python that will it's called like a biggest triangle 3 buckets, and decimating data down into smaller bits to be able to play with it more, because sometimes you get a lot of overhead with millions of data points all at once, and so the decimation of data is pretty fun. But so the last triangle, or largest triangle 3 buckets algorithm, I actually published that up on GitHub, on my GitHub. JavaScript that is incredibly small. I was able to render things real time in the browser that used to take half a second down to like 35 milliseconds now. So pretty awesome game right there.
Yeah.
But do check out the earthquake transformer thing. It's pretty cool. It's been done recently. It's a cool neural network to train to pick PNS waves. And
I just wonder what the strategy is for it from the model standpoint. If they're using something visual, like with a convolutional neural network, or if it's some other, like, I just wonder how they approach it. Interesting stuff, though.
Guys, I've got to run. I'm being called for lunch. Good to see you all.
Yeah.
Good seeing you.
Yeah, good
Sounds
seeing
good.
you.
Yeah.
We lost all the IBM people on the call.
Yeah, I know. Yeah.
Sort of feel bad. We must have been boring or something.
All right, we'll see you guys.
All right.
Okay,
Yeah.
take care.
Yeah.
I'll see you guys.